All right. So good afternoon once again, and welcome to BayOne Bootcamp. And can one of you tell me if you can see my screen that I'm sharing right now, please?
Sure can.
Wonderful. Thank you, sir. And for some reason, I'm not able to get to the slideshow mode. Okay, I'm able to do that now. So thank you, folks. My headset is not working. I'm on the speakerphone, so apologies if you are hearing some background noise as well. Okay, so we are BayOne, and this is part of our weekly Tech Bootcamp series. Welcome. Many of you are joining us for the first time. We do this on a weekly basis on different topics ranging from software development to other digital technologies like big data, IoT, cloud computing, DevOps, AI, and ML. Today, particularly given the nature of the topic, we will be talking a little bit about AI machine learning, particularly natural language processing and chatbots. So these are informational webinars. Everyone is welcome to join. We do this on Tuesdays from 4 p.m. to 5:30 Pacific time. We usually have an industry expert hosting the session. I usually coordinate these sessions. My name again is Suva Sharma, and please mark your calendars in advance. Typically, we don't send out invites given these are webinars, but we do share a Zoom link with a password just prior to the meeting. So everyone, welcome to our session today. Just wanted to call this out. We do have an offer of free mock interviews for all technical candidates. So if you are a software developer, either working on backend, front-end, or full-stack technologies using Java, JavaScript in particular, send me an email. My email address is shared right there, sharma@bayone.com. If you just describe your role briefly and what kind of domain you're interested in, attach your resume, we will do a quick mock interview session with you. We will be giving you some problems that you will be asked to solve, right? These are problem-solving, typical interview simulation kind of exercises. And then once we are done with that, we will give you recommendations for improvement. Some of you had reached out, looking for a job in the recent past. So particularly if you are between jobs, or if you're looking for something new, or if you are looking for, getting to that next level in terms of your programming capability and problem-solving skills, I think something like this will definitely help, right? But we do have limited bandwidth. Our resources are constrained. So whoever gets in touch with us first, only via email, please. You have my email. You should have received the Zoom link. Please reply to that saying you're interested, and we would gladly schedule a 40-45-minute session with you where we can do a quick review, and then we'll give you recommendations. Hopefully that will be helpful as well. Okay. So given today's session is fairly long, I would advise if you have any questions, please hold it until the end of a special segment. And when we pause for questions, you can ask your questions. Any questions regarding these mock interviews? Okay, good. So we'll move forward. Recent stats, only 2% selection of candidates typically who go for technical interviews or who come to us for screening. It basically means two things. The competition is tough, right? Number one, and number two, unless you're really, really, really well prepared, the chances of success are very low. So even if you're coming to us for a mock interview, please prepare yourself. And in our other bootcamp sessions, we have spoken with you in detail about how to go about preparing yourself, right, for these kind of interviews. Okay. So it's my utmost pleasure today to welcome our special guest speaker, Rishi Agarwal. He is the CEO of Techvision Group. He's also an investor, an advisor for Talking Mart. He's built some really cool products and services, and some of the bot platforms that you might have worked in might have been designed or supported by Rishi. Rishi works with several Bay Area companies in a consulting role as well, and he'll be sharing some cool ideas today about natural language processing, typically its evolution and its use on chatbots, and what are some of the cool recent developments in that area. So we will go to Rishi in about 25 minutes. His session will start at 4:30. Just wanted to extend a warm welcome on behalf of BayOne Solutions and everybody on the call. Rishi, good afternoon to you. Hi.
Thanks for having me on the call, Suva. Appreciate it.
Absolutely, absolutely. Welcome, sir. All right, so very quickly, we will go over the introduction to AI and machine learning. Again, that is just a prep in terms of how, AI and machine learning sort of work at a very high level. It's like a crash course. And the only reason we are doing that is because Rishi will be then taking that forward significantly in a more advanced level when he's going to talk about natural language understanding, NLU as it is called, natural language processing, NLP, and its evolution of chatbots and a bunch of other things that we'll talk about once we get to Rishi. All right, any questions so far? Okay, so the crash course begins now. Why is the hype in AI? And the reason is obvious, right? This is a slide I presented for one of my clients about 3 years ago. And even at that time, 80% of Netflix videos, 80% of watched videos on Netflix were coming via recommendations. 80%, which means your recommendation pretty be good. Otherwise, the viewers are not going to watch it, right? 50% of Gartner's predictions were using AI machine learning algorithms, again, using recommendations. Amazon sales, 35% of Amazon sales 3 years ago were happening for recommended products, not necessarily the product you were originally interested in, but something that Amazon recommended to you as an alternative, okay? These numbers since then have even gone higher, right? So Netflix, for example, once you create an account and once you have a fairly significant footprint, depending on a bunch of factors, it makes recommendations. Now, the reason you have to use AI is because it's not a simple algorithm, right? Depending on the day of the week, the time of the day, and the kind of device I'm watching, Netflix on, the recommendation might be very different, right? On a Saturday afternoon during leisure time, I'm interested in watching something else versus if it's a work day, there might be a different preference. And over time, it's able to understand this, how I rate titles, what kind of tastes do I have. Human beings are not single dimensional objects. We are multidimensional. We are multifaceted. So all the more it makes recommendations even more difficult, whether we are recommending movies or clothes or audio, anything for that matter, right? And that's why we have to use some form of artificial intelligence because regular algorithms don't quite work. All right. Just a request, folks, everybody please mute your lines. Thank you.
Yes.
Hold on 1 second, folks. All right. Okay. So in 2018, 850 million kinds of malware were created. Now, these are not just, instances. We are talking about different kinds of malware. Just look at the volume, right? 6 trillion worth of damage is what is predicted will happen via different forms of cybercrime by the year 2021, okay? And as of now, IT budget on an average is capped at around 1.5 to 2% for fighting these kind of cybersecurity threats, which clearly means we got to do a lot more based on the budget that we are given. So we are not able to use conventional technologies. We are not able to use conventional approaches. We have to use AI, right? Also in medicine, right? Initially, it was used for detection only, and eventually it was used for detection and quantification of a given condition. And then as things improved, detection, quantification, and prediction based on a bunch of symptoms, what a patient is potentially going to get or how they should be treated in advance so that they don't end up with that kind of a disease, right? So I'm just talking about the different kinds of progression that have happened in the field of AI that has really made it hot. Another interesting concept in AI is called transfer learning, which basically means You've created a model that works on a data set X. Okay, this example is typically about a financial analyst. He looks at a bunch of charts and figures, NASDAQ, S&P 500, right? And he builds a bunch of reports. He uses some AI models. But very interestingly, he is able to transform that learning and use it on a data set which is completely different, right? In the field of medicine to diagnose some kind of a heart condition and predict whether that's good or bad, right? So you looking at the stock market numbers and then predicting whether in the future the stock market is going to perform good or bad, sort of similarly can be translated into the medical domain using a similar AI prediction model, and you come up with a heart disease um, prediction even better than a qualified doctor. Actually, this was a major article in the Wall Street Journal. This is also about 4 years ago now. So if you remember around 2016 when Alexa came out, and then Google Home and all that stuff, there was a lot of communication around AI and how things are going to be dramatically different going forward. Now, not a lot of those things, not all of those things have come true, but they are progressing in that direction, right? So many of you on this bridge actually joined our cohort that we conducted late last year on data science. And this might be a refresher course for some of you as well. So I see there is some chat activity going on. Let me just double check to see if there are any questions. Okay, all right. Let me continue on. So we saw that the concept of transfer learning can be applied from something as varied as a stock market prediction to be used in the field of medicine, right? That is very interesting. Now, one scale of how AI has progressed over the last several years is this open competition called the ILSVRC, the ImageNet Large Scale Visual Recognition Challenge. It's an open challenge where a bunch of AI enthusiasts join, and given a bunch of pictures, there are about over 1 million pictures, actually, over 1,000 categories, and they are given 50,000 images to look at and then calibrate their systems. And then they're given a test. They're given a test of 100,000 images. And then based on how they have developed the model and the 1.2 million images that they have used to create an AI model, they have to predict, right? Or rather guess what these 100,000 images are, whether it's a cat. If it is a cat, what kind of a cat is it? Is it a domestic cat, Asian cat, Siamese cat? What kind of cat, right? Is it a tiger? If it's a tiger, is it a Bengal tiger? Or is it, a Java tiger? Something like that. So traditionally, humans are at about 10% error rate, which basically means if I show you an image, a random image, from online, 90% of the time you'll be accurate, okay? 10% of the time you'll be wrong. That's an average human being. Now, if you are a subject matter expert, on an average, again, these are again very average numbers, okay? You'll be right 95% of the time, and 5% of the time you'll have some error. And if you see right at the top, it shows in French notation actually 5,0 means 5%. The humans typically are at around, expert humans at around 5% error rate. Now, look at the other bars. In 2011, the cutting edge AI, image recognizers were operating at 26% error rate, which means they were right only, 3 times out of 4. There was no competition with humans, right? ILSVRC was introduced in 2012 that brought the error rate down from 26% to 16%. Significant. That was in fact a breakthrough. But still, it was 3 times worse off than a regular, or not a regular human being. It was still worse off, by 6%. But then even to compared to an SME, it was significantly bad, right? But then look at this, 2013, 2014, GoogleNet in 2014 came very close to humans, and then ResNet from Microsoft beat the humans 5 years ago. And that is when things like, Alexa and a bunch of other AI solutions that you are now very acquainted to enter the market, right? Again, we are talking about visual recognitions right now. We're not talking about audio recognitions, but anyway, just wanted to give you an idea. And even as of 4 years ago, from Google, solutions, they have created some ensemble approaches, as they are called, to reduce the error to under 3% now. In fact, I believe it's even slightly under 2% as we speak. So things have gotten really good. There are different approaches in solving these problems, from a concept called feature engineering to something called CNN, or convolutional neural networks, right? As is shown on the bottom left of the slide. All right. Now, translations. Translation is a big space, and to some extent, this will be touched upon by Rishi as well when he talks about natural language processing. But when we are talking about translating from one language like English to Spanish or French, if you look at it, Google Machine Translator, even 3 years ago, this is a stat from late 2008, 17, so almost 3 years ago, you can see that the Google Machine Translator is operating almost as good as a human. And off late, probably they have gotten better, right? I know that even my Siri that is kept right next to me, and she might just get activated as I speak her name, is really good now at recognizing my voice. She can recognize me, she can recognize my accent, and she understands the intent, right? Things like jokes, sarcasm. AI has really progressed, okay? Google AI, Google Duplex was something that was really cool. I think last year, Sundar Pichai had a live demonstration of how a bot actually called a restaurant and placed an order. And the person taking the order in the restaurant had absolutely no clue that she was actually replying to a robot. So this was state of the art last year, and things again are getting even better, okay? All right, so why are companies getting crazy about AI? Is even as early as 2014 and 2015, within that 1 year, company executives said that their return on investment on relatively low budget AI investments were significant, especially in the field of telecom, where there was a lot of error processing happening through manual and semi-manual methods. They started using AI, and their return on investment was about 20%, which was pretty good, right? So as you can see, different industries have been impacted in different ways. Retail, of course, thanks to recommendation engines, there is a significant impact in a positive way. High tech, insurance, again, people making predictions, banking, financial services. So there is a reason why AI suddenly took the world by storm and continues to do so. All right. PricewaterhouseCoopers in 2019, or no, wait a second, this was from 2017. They had predicted that over the next 3 years, there will be significant expansion of AI and AI-related work activities. And that between 2015 and 2020, there would be a jump of up to 45% in terms of how data scientists and engineers are hired. And that was also another indicator that AI would continue to grow and progress, okay? So just wanted to throw this in there. Relative to the growth of some of the other mainstream programming or IT-related jobs, data scientists, data engineers, the growth rate was significantly high. But as you can see, the population is small, so of course that is also a factor, but they are in a very high growth segment. And I think I read an article on Gartner about 3 months ago that in fact the actuals far exceeded what the predictions were from PwC that were made a few years ago. So AI actually really grew. Now, the growth curve of AI was definitely not linear. The initial approaches, what we call as good old-fashioned AI, right, worked on methods using heuristic search, and these were popular in the 60s and early 70s, and then things didn't quite progress. And then this concept of knowledge engineering and expert systems and a bunch of things, Prolog list programming actually became very active. For people like me who entered the world of programming at that time, list processing, Lisp, for example, was pretty hot, right? So this was the advent of expert systems. A lot of our colleagues, and classmates did their projects using fuzzy logic and expert systems. I remember there was also a washing machine, right? Which in its ad used to say that, okay, this is Videocon washing machine, and this has expert system in it, and people had no clue what an expert system meant. But anyway, then came the 90s, and there was a long winter of AI because the models were not getting any better because they were constrained, right? They were constrained by processing power, and they were constrained by memory. But with the advent of GPUs now, suddenly that door has been opened. So now you can process way more instructions. You have almost an infinite, amount of memory, and there are so many efficient ways to run your algorithms that things just took off. So after the second so-called winter of machine learning, AI, machine learning took off, and then eventually what became deep learning, right? So it's been growing. Now there is a concept regarding data engineering. I just wanted to mention that, and I know I have about barely 10 more minutes to go, so I really have to run through these slides. So Netflix in the year 2009 had a competition saying that they'll pay $1 million to any company, any team that betters their existing recommendation engine by 10%. As you saw, if 80% of their recommendations, if 80% of their videos watched are coming from recommendations, then definitely this was the core of their offering, right? So this team that ended up winning, right, and they won $1 million, they improved the model by 10%. Actually, they improved it by about 11%. Netflix looked at the solution, but they didn't use it. And you know why? Because there was a lot of pre-work that had to be done, which would cost Netflix a lot of money, and it would cost them so much that it wouldn't be worth the 10 or 11% advantage that they got. So lesson number one in all of data science is that it is not just the prediction that is important. All the other aspects, particularly the engineering aspects of data, when you get the data, how good is the data, and engineering it to make it usable for your model is equally, if not more important. And as this famous slide from Google actually calls out, the machine learning code in typical solutions is barely worth 5% of the effort. Everything else in data science is about data collection, right? Extracting features, validating it, monitoring it, analyzing it, processing it, pre and post processing, and a bunch of stuff. So when people talk about building cool designs and cool models, remember, they are just talking about the 5% of what sits in the center of the ecosystem. The other 95%, if not more, are all the ancillary systems that support the core machine learning model, okay? So this is a picture of how a production lifecycle of a data science, data engineering model looks like. So there is business, there is data acquisition, there is modeling, there is deployment, there is IT involved in all of this, right? There are statisticians. So I just wanted to show that it is a big ecosystem. When you are designing a model initially, you'll do it on your laptop, right? Using a Jupyter notebook or something. But then when things go into production, it has to fit in. And that is the more difficult part, as I showed in an earlier slide, that eats up 95% of your resources. Okay, so AI, machine learning, and deep learning, how are they different? AI typically is used very broadly. Machine learning is a subset of that, wherein without explicit programming, your system learns to look at data and then be able to develop a program around it, rather than starting with a program. And then deep learning is even a smaller subsection of machine learning, where you don't have to do a step that is called as feature engineering. I'll talk briefly about that in a second, okay? However, AI, again, these are very relative terms. Sometimes people use the term AI to actually mean deep learning, but traditionally speaking, AI has been around for a long time. AI basically means using an artificial, system to emulate or mimic the human behavior. That's it. When you're using some kind of a digital solution, computer that is, to mimic human behavior, the way we think, that is AI, period. So that it's very transcending, right? Whereas machine learning is a little more specific and deep learning is more specific. Again, these are definitions from towards data science. There are many online resources that you can look at. Okay, another interesting concept I wanted to touch upon was the distinction between inductive and deductive reasoning. What is the difference? Traditional programming, where I give you the logic and then based on that logic you write a piece of code, is called deductive reasoning. As in, if I say that my weight is equal to my age times 3 plus 15, that is called deductive reasoning. There is a formula, it is fixed. Typically, once you have such a formula, once you know the relationship between your unknown variable, between all your known variables and the unknown variable y, right, which is a function of a bunch of x's, x1, x2, x3, that is all deductive reasoning. If I gave you the formula, you don't need to use AI, you just use the formula, right? But there is something called inductive reasoning. As we were growing up, right, our parents taught us the difference between a cat and a dog. They did not explain to us. They didn't say, if the ears are pointy, then it is a cat. If the ears are slightly drooped, then it's a dog. If the distance between the pupils of the eye is less than 3 centimeters, then it is a cat. If it is more than 5, and if it's sideways, then it's a dog. Were we ever taught like that? At least I wasn't. What my parents did was they showed me a dog and they said dog, right? And they showed me a cat and they said cat. And then later on, I saw a dog, which to me as a 2-year-old looked like a cat, and I would say cat. Then they would correct me. They would say, no, that's not a cat, that's a dog. So this concept is called supervised learning. They are correcting me. So I'm giving them the output, they are correcting me. So it is going into my brain, but it is not deductive reasoning, it is inductive. I learn it one data point at a time. It's statistical, right? I look at 10 dogs, I look at 10 cats, and over 1 year, 2 years, 3 years, by the time I'm 5 years old, 99% of the time I can accurately distinguish between a dog and a cat. But even then, if somebody, or even now, if somebody were to ask me without showing pictures to write a paragraph differentiating between a dog and a cat, do you think I'll be able to do that? Probably not, right? Because you have to show them the picture to be able to learn that. So there is a distinct difference between deductive reasoning and inductive reasoning. AI, machine learning, deep learning works incredibly well with inductive reasoning, which means there is some kind of a correlation between all the inputs and your output, but there is no algorithmic dependency per se. There is no set logic. There is no y equals to mx plus c. You have to derive that based on your data points. Okay, so that's the difference between traditional programming and machine learning, where in traditional programming, you have to write the program, you feed the data and you get the output. But in case of machine learning, you give a bunch of output, you give a lot of data, the machine itself tries to generate the program and then tries it multiple times through a process called supervised learning. Typically where you say, yes, dog, yes, cat, no, that kind of thing. And then over time, it's able to, make its prediction better and better and better. And that program that you develop is essentially called your model, okay? All right. Now, typically, there is a concept of perceptron that was, formulated or proposed about more than 50 years ago. And this is nothing but like, writing the equation of, based on a bunch of unknown variables where there are x1, x2, and x3. If you have to predict the price of a house, and that is dependent on a bunch of input parameters like square footage, number of bedrooms, zip code, that is x1, x2, x3, whatever. And each of those input parameters has a weight. You combine them together, x1 times w1, x2 times w2, and add them all up, right? That gives you the value of y. Now, you know that x1, x2, and x3 are somehow correlated with y, but you don't know how much. You don't know how much of a weightage zip code has over number of bedrooms or over your square footage, right? It's for the model to figure that out. So this very simple model where there is just one layer in the middle, that blue dot that you see, that takes in a bunch of inputs and is able to identify what should be the distribution of W1, W2, W3 up to Wn to predict the right value of y is called a perceptron. And it is the fundamental building block of typical AI models. And you just combine them together into multiple layers and form something called a neural network. That's what it is. Multi-layer perceptrons or MLPs are nothing but models that have one or more hidden layers in between. Okay, so I think I just hit about 4:30. I might need about 5 to 7 minutes more. Rishi, is it okay if I just jump through the remaining slides fairly quickly? Are you good?
Absolutely. Take your time.
Okay, thank you, sir. All right. So distinction between machine learning and deep learning is that in machine learning, there is an extra step called feature extraction. Typically in the example of the house I showed you, right? X1, X2, X3, you can take combination of multiple things and decide how you want to use it. And the only reason people do that is because if you don't do it, and if you have 100 input points, then your model gets very complicated mathematically from a processing perspective, right? So we didn't have processors good enough to be able to do that until very recently. But now with the advent of GPUs, we don't need to do that. So all we do is we feed in a bunch of images, millions of them, like you see the car here, right? And the model itself is able to do the feature extraction as well. So that is the basic difference between deep learning and machine learning. Essentially, in deep learning, you'll have 4 or more layers, right? Unlike machine learning, which maxes out typically at around 3. Okay, so there are different kinds of models. I mentioned about supervised versus unsupervised. Supervised basically means somebody is there, or the your program, based on the output, is able to validate whether or not your output was correct. So it is able to feed that into the system and then correct itself. That's called supervised learning. As I was saying, this was dog, that's cat. My parents were saying, no, it's the other way around, supervised learning. However, unsupervised is a little different, right? If I don't have an expert to ask the question, and if I see a bunch of dogs and cats, if my model is good enough, I'll be able to cluster or club all the dogs together. I'll be able to club all the cats together. I don't know what to call them because there is no name. It is not supervised. They don't have a quote unquote name label, but I know they are different. I know this is one category of things, and whatever you call it, right? Eventually dogs, and the other is a group of cats, right? So that is the difference. And then there is another type of distinction called regression and classification, okay, within supervised learning typically. And essentially what it means is regression is nothing but a numeric prediction. It's like a continuous numeric function. So like predicting the price of a house, it could be anywhere from 0 to 999 million. So the value of your house could be any number in between. Whereas classification is a typical example. If you have to predict looking at a picture, is it a boy or a girl, right? Is this student going to pass or fail? So there are distinct values, but not continuous values. Okay, so that is classification. The former one is called regression. I've mentioned about a lot of things. Logistic regression is a form of classification. So typically, when you are working on an AI problem, you get a lot of data, right? And how do you use that data? You break it down into typically 3 parts. The first part you use to build your model, and that's called training data, okay? Once you have trained your model and you come up with fairly accurate predictions, then you use the second part of the data that you had kept aside, which is called validation data. That is checked to see if your model was actually accurate enough and to do some fine tunings, right? And after you are done with that, you use the third part of the remaining data that we call testing data and then test it on the model. And then if you are still getting very accurate results, it means your model is really good. If not, it means your model was, needs to be re-engineered, right? So training data, validation data, testing data, basic difference. I'll not touch upon this. There are 3 sort of dimensions that you're working on, typically working on AI problems: structured versus unstructured data. So, Rishi will be talking about natural language processing. So he'll be talking a lot about unstructured data as well. Supervised versus unsupervised, I talked about this. Regression versus classification is whether, your output is classifying itself as, black or white, boy or girl, versus a regression problem where the output is more of a continuous, numeric value. All right. Okay. Another thing, why is data becoming so important now? The reason is machine learning algorithms, because they had a manual or semi-manual feature engineering step, their efficiencies, their prediction capabilities sort of maxed out, their level of accuracy maxed out after hitting a certain data size, they couldn't get any better. But as you saw with ResNet and some of the examples I showed, right, starting 2011 and 12, with the advent of deep learning, because you have so many infinitely more combinations of solutions possible, that the more data you have, right, your solution continues to get more and more accurate. Now you see that line is definitely not exponential, it's not even linear, but still it is increasing, it is getting better, unlike ML, which is sort of, gone asymptotic, right, at a certain value. So that is why data becomes all the more important with deep learning solutions. And that's why data is the new oil, as they say. All right. I have a bunch of other things. I will not touch upon that. I'll just go through this very quickly. When you don't have enough data, you do some process called creating synthetic data. But we probably don't have the time for that today. I'll cover all these interesting things at a different point in time, folks. For images, there is a concept called convolutional neural networks. And if you see the graphics on the screen, you're seeing CNN in action, how it is used to predict images, right? And it's a fairly cool solution. So before I hand it over to Rishi, I just wanted to bring up the reason why it's not very easy and it's not very intuitive to come up with a chatbot solution. It is not very easy to understand and comprehend. I've been talking for the last 35 minutes, right? But because we as human beings are so trained into understanding how conversation works, we have frames of reference, we have a good memory, we are able to understand each other fairly well. Look at that big blue ball on the screen, right? If I were to ask you, this was a picture of a ball, I took. Can you tell me if it's going to go left or right or top or go to the bottom? The answer is no, because you don't know. For that, you need to know where it was a short while ago, right? You need to have some context. You need to know some history. Now look at the ball. It's been moving from left to right. And now if I ask you, where would it be in the next frame? You know exactly it would be to the right because you have context, you have history, right? So recurrent neural networks works on a concept of sequential memory. And it's very interesting to see, if you look at letters, right, A, B, C, D, E, we have memorized it like crazy. Even 2-3 year olds can do that. But even ask a 50-year-old to spell it backwards, go ZYX. I cannot do it. Can you? This is the reason why sequential memory is ingrained in our heads. And that is very important when it comes to deciphering natural languages. So recurrent neural network is a solution to do that, right? And the way it does it is, if you have a sentence like what time is it, it builds itself based on the individual word components. And then whatever is the output of the first, it feeds it into the second and then to the third and so on and so forth. The moral of the story being that it does not lose sense of history. It keeps history intact. But then as you keep progressing from what to time to is to it to the question mark, it knows that the question mark was that the question is the last part of the statement. So it knows it's a question. But by then, if you see, the input from what has become really small, right? So this is a problem called short-term memory that Rishi might actually touch upon. So recurrent neural network is able to decipher that, hey, this is asking for time and it's a question, the concept of vanishing gradient, and there are a bunch of things. So for example, you're looking at this text, right? You're looking at this text. You don't need to read everything. There are the keywords are here. Amazing, perfectly balanced breakfast. This is Thanos, giving his recommendation on a box of cereal. And then, but then there are 3 key segments that you need to know. And there is also memory involved. And this was again an example of RNN. There are a couple of solutions to work around, RNN's limitations. And there's also a concept called random forest, which is a classification technique that mentions that, a bunch of people or a bunch of models that are uncorrelated actually predict better than a very wise model, right? With that in mind, I'll share these slides with you. With that in mind, I have to transfer to the wise man we have in the room before we run out of time, right? So Rishi, about 10 minutes late, sir, but I'm handing it over to you. Rishi Agarwal is again our esteemed guest today. He's the CEO of the Techvision Group. I've worked with Rishi on many collaborative projects, and he presently is an investor and advisor at Talking Mark, and he will be educating us today on natural language processing, in particular, the evolution of chatbots, and he's going to talk about some really cool models. So, Rishi, I'll just stop here and over to you.
Thank you very much, Suva. So I will share my screen. Give me a second. I am not able to share my screen, Suva. Let me.
I need to make you the co-host for that, Rishi. Just hold on 1 second, and I will do that right away. So I have made you the co-host now.
Excellent.
So you should be able to share the screen. So as we are doing this transition, and my sincere apologies, we went over a lot of content with a lot of speed. Any very high level questions, folks, so that, and Rishi, please feel free to answer the question. Any questions so far in terms of the context, what we are talking about today and what we are going to talk about with Rishi? Okay, Rishi, we can start.
Outstanding. So first of all, many thanks to Suva and to BayOne for giving me the opportunity to speak here today. Would have been awesome to have a session like this in person, to see you all and get together in a room and talk about some of these things. But we'll do the best we can with this kind of a Zoom kind of model as well. A little bit about me. As Suva said, I run a consulting firm called Techvision Group. Been a serial entrepreneur, angel investor, love building companies and building things. I've been here in the Valley for more than 20 years now, seen my sort of fair share of ups and downs and booms and busts. And I don't think I can live anywhere else in the world. Nothing else matches the kind of sheer exhilaration of being here in Silicon Valley. My current investment areas of focus are all around these concepts: data science, applied machine learning, predictive analytics. And mainly the focus is on what we can do with these things. And so Talking Mart is one such investment that we've recently made. And it is in the area of chatbots and virtual assistants. And I thought we'd talk a little bit about, not necessarily Talking Mart, but just in general, the concept behind virtual assistants and how they can perhaps be of use both in your company and potentially in your career as well. So I've got about a dozen odd slides broken out into a couple of components. One set kind of talks about what these are and a little bit of context around them to help you understand the space. And then another set of slides kind of goes into a bit more detail. It sort of picks up on some of the points that Suva brought up about RNNs and language processing, and goes into how some of these assistants are actually built. So that's kind of what I have. About 40 odd minutes. Normally, I love to make it interactive. I don't know how much we can do it with this kind of a model, but off we go.
Yeah, so our target time is around 5:30, but please, most of our sessions, Rishi, easily extend up to 6 o'clock. And having your presence today, we wouldn't mind going over time as long as it works for you, okay? So thank you.
Absolutely, absolutely. So let's start with what are conversational assistants, aka chatbots. Very simply, it's a software program that conducts a conversation with a human, most commonly via a text or a text-to-speech interface. So the simplest, broadest, most generic definition of what a conversational assistant is. These have been around now for quite a few years. It seems like everywhere you turn, people are sort of investing time into this, investing effort into this. And I have a slide a little bit down, maybe the very next one, that talks a little bit about what the ecosystem around this looks like. But let's spend a couple of minutes talking about really why is this so interesting. Um, and you know, if you look online, there are so many different things that talk about it. You get drowned in information. But I wanted to highlight a couple of things. In that, first, if you see on the right, and the slide is a little older, and the numbers are even more now, where messaging apps have surpassed the social networks. Facebook Messenger just came out some years back, and we thought that, what's one more messenger going to do? And now you see the volumes, the millions and millions of messages that are on that. WhatsApp, of course, it's explosive success. And we are finding that a lot of people are actually very comfortable having these conversations on these chat apps. In fact, I would venture to bet that most of us, we spend a huge amount of time on things like WhatsApp, even if it is reading jokes from people or just chatting, but these platforms are indeed very big for all of us. And then what that has led to is really the understanding or the appreciation that, hey, I don't need to be talking to a human being to get my work done. I am very comfortable talking to a system so long as people are focused on what my question is, what I need, and I want it now. So here's a little survey in terms of why might somebody want to use a chatbot. And you are seeing that it's all around being available 24/7, being available right now. And if you look at it, these apply across age groups. It is not necessarily your young millennials that are believing in this, but everything up to baby boomers as well, who appreciate the always on 24/7 fast way of getting an answer. How many of us have made a call to customer service and been on hold for 20 minutes? How many of us have gone through these very painful IVR systems? You're pressing 6. Please listen to the entire menu as the menu has changed, and you spend 8 minutes simply listening to the menu options. There is no way to navigate back and forth, for example. The amount of information that you're seeing out there is just staggering. Petabytes of information coming out on a regular basis. And in fact, this is one of the things that we are focusing on is in the world of e-commerce, there is just so much data that how do you decide which version of the product you want to buy? So point being that paradoxically, there's a ton of information out there and it's very hard to make sense of, which is where these chatbots come in that they distill the information down quick. So you can see easy communication, speed, a good experience. These are things that people really care about, and hence all the hoopla around these chatbots. This, I wanted to get one slide that talked about the entire ecosystem around all these chatbots and virtual assistants, and I could not. There are just so many players out there that it is unbelievable. Seems like everywhere you turn, people are getting into it. This actually made me stop and look a little bit in more detail about what exactly is how exactly is the space structured. And I thought that this slide from O'Reilly looked like it's a little old, but it gives a very nice sort of breakdown in terms of what the ecosystem looks like. So if you look at it at the very top, you have your big guns, right? I am personally convinced that these companies are going to take over the world, if not already, right? And each of them has a player. You have Siri from Apple, you have Google, you have Alexa from Amazon, you have Cortana from Microsoft, and you have Facebook Messenger, which is, since this slide was created, it's big enough to be a general AI agent on its own. We already talked about all these messaging platforms. Each of them boasts a fantastic reach in terms of the people that are on it. You have your Slack, and now you have Teams, and you have Kik and Telegram, you have Twilio. So all of these are massive. And then these are sort of your, and we'll talk more about these as we go into the components of a bot. But these are really your ways to interact with the world. It is rare these days, or rather it's hard to imagine that, oh, I'm going to come up with a brand new platform that everyone's going to move to. Sure, theoretically anything is possible, but the best way of spending the time and effort would be to assume that you're going to be on a platform that everybody else is on, and then build a value-added solution on top of it. Now you have the messaging platforms, and then on that you have the really core machine learning, natural language, artificial intelligence type platforms. This again is very interesting. Suva had the presentation that called out a lot of detail in terms of what machine learning is and what deep learning is and all that. And you know, if we were doing this in a one-on-one class or in a live class, we would have asked how many folks really understand the math behind all of these things. And the answer is very few. And what is happening is that, again, these big guys, if you can see these logos, they are all, again, the same big guys at the very top. They are investing tens of millions of dollars into the core fundamental research. What used to be the function of universities, now most of these guys are doing for profit to build solutions. So now you have all of this as well that is available to you. I was talking to someone and we were talking about a multi-language solution. And this gentleman is from India. And I said, yeah, you know, if you have to do Hindi, and he just cut me off and said, hey, don't even talk to me about Hindi, because Microsoft has a API, a voice API, where you can speak to it in Hindi and it's going to translate it in English text for you. You don't even need to worry about Hindi, it's solved now. So these guys are building huge platforms with the kind of data that you and me can't even imagine. But the beauty of it is that they are solving the hard problems, for which then if you look at the next level is when you have the actual bot frameworks that you can build on. And I have some here in this, and then some new ones that are here on the left. And these are bot frameworks that essentially say, hey, I am going to take all of these components and I am going to put it together into a chatbot virtual assistant solution that will solve my particular problem. So the good news is that, hey, you have so much fundamental research and so many platforms that you can leverage, freeing you up to focus on the specific mechanics of your business problem that your chatbot is going to solve. So having said that, right, I mean, I've been around in the valley long enough that you always have to look at what the real world is before you buy into the hype and the hoopla. And along with all these success stories, there have also been epic failures out there. You can just look up some of these online and, you know, they're certainly good enough for a chuckle. Perhaps the most interesting thing for me is the Turing test. People have claimed that finally it's been passed, but not in any meaningful way, according to me. And that there is still quite a ways to go. And what I find most interesting about this is the fact that you and me, I mean, maybe I'm wrong, but most of us, we are not going to say, oh, let me build the next Amazon Alexa or let me build the next Siri. We typically have a practical problem that we want to solve. We have a fixed budget. We have a bunch of demanding customers. We don't want to piss them off. And so our goal is to provide a very narrow solution that solves one particular problem. And from that standpoint, we are living in an especially good time right now to go and build something cool. So this was a little bit of introduction in terms of the world of chatbots, what the ecosystem looks like, and so on and so forth. I just wanted to pause for just a brief second here. Does anybody have any questions on any of this so far? Okay, so now let's digress a little bit and let's go into the actual components of chatbots. What these are, how does one go about building one, and what are some of the sort of under the hood things that we need to be aware of. Again, I'm not going to go into code, or I'm not going to go into any of that level of detail, but my hope is today to talk about the architectural components, so that when you go and turn on your phones or your laptops and you go doing Google search on Stack Overflow, you will be able to make sense of what you see out there. So first and foremost are these rule-based chatbots. That's kind of where the phrase chatbots came from. And as the sort of name says, they are rule-based. They are essentially state machines where you build them with if then else based hard-coded rules. So the good news about it is that they are very deterministic. It is absolutely clear. You know exactly why the assistant, why the chatbot did what it did. Because of this, they are also very easy to start with. You can whip together a workflow, and you can convert that workflow into a chatbot with using many of these platforms I showed on the previous slide, and you're off and running. So speed, very good. Deterministic nature, very good. But of course, as your assistant, as your chatbot begins to get even little bit complicated, these become very hard to maintain. Rules tend to conflict with each other. Rules morph and become rule flows. You may have a slight variation in what the user says, and the assistant is unable to handle it. And you will see a lot of websites right now have these right now. Next time you see a chatbot, try to throw something at it that is not in line with what they are asking for, and immediately you will say, oh, I'm sorry, could you rephrase? And now this has gotten so bad that people don't even give you a free-form chatbot. They will just give you 3 options and make you select. Hi, I'm so and so. I can help you with. Browse the site, get more information, talk to an agent, and you have to just choose one of the 3. That to me is not really a chatbot. It's just some form of guided navigation. That's all that it is. But these are easy to go live with, and certainly if you want some quick and dirty information, these can be pretty good. But what we are now is at the stage of what we can truly call a conversational assistant, where we are leveraging some of these advances in natural language processing, some of the points that Suva just mentioned. And the idea here is that you are conducting a conversation, and the assistant should not only be able to understand the context, but also to be able to deal with the change in context. So these are the most important things here, and we'll see a couple of examples of this, that the assistant very rapidly has to make a determination as to what is it that we are talking about. Once it makes a determination of that, it needs to keep it in some memory, and then based on that, it has to respond based on some kind of business logic that it has. So this is a very important thing, in that now all of a sudden you have deviated away from the sort of easy, well-defined, rule-based logic, and you have entered into the world of natural language processing and machine learning. Now, I will take a 1-minute digression here and bring up one point that at least I have seen lately in my journey in this field. A lot of the times when you present something, whether it is to a business executive or even to your family, you are making some kind of a claim, people ask you, hey, why do you say that? What made you come to that conclusion? If I were to go on to this sort of a rule flow, And if I say that the bot asked me to enter my order number, I can very easily walk it back and know where it came from, because it's very deterministic, very clear. Machine learning, because of the very nature with which it is built, because of all these models, because of all these coefficients that get calculated, because the problem actually just boils down to complex matrix multiplication, it is very hard to reverse engineer back as to why the particular algorithm came up with a particular answer. And you will see this happening more and more in the world today, where things like AI bias, things like machine learning bias, nobody can explain why the algorithm recommended a particular option. It's too complex. And so that is one of the very, very important things. I think it's a definite area of enhancement in the field of machine learning that you will see a lot more of. And as you start to see the design of these things, these conversational assistants, you will see that it's very important to keep track of why we are saying what we are saying, and not just come up with some kind of black magic. Okay, so that was a little bit of a difference between these deterministic state machines and a proper conversational assistant. Let's now dive a little deeper into what are the key components, key architectural components of a conversational assistant. Okay. The way I see it is it breaks down into 4 sort of major components of the system. And you will see this is not exactly path-breaking knowledge. Most sites out there have some version of this that I'm talking about. At the very beginning, there is some kind of a conversational channel. People need to communicate with you, and it's through these. If I flip back and I'm going to remind you of all of these sort of messaging platforms, aka conversational channels, communication channels that people will reach out to. So that is a component in that the assistant needs to listen to any conversation there. But of course, this is a purely integration activity here that, hey, I need to be on Slack, and I need to be on Teams, and I need to be on Facebook Messenger, and I need to be on WhatsApp, and all of that. The big guys control that channel. You have to sort of obey their rules when it comes to creating an assistant on their channel. Facebook has an approval process, and Slack a little bit less so, because Slack is on your own channel. Google has the new business messages where you have to go through approval. So if you are on their channel, then of course you have to go through that. But the benefit is that these channels, you don't have to worry about UI. That is one of the biggest things in terms of this kind of a product. You don't have to worry about navigation, or you don't have to worry about CSS and colors and just a little bit of it to make it work. But otherwise, you are following the trends and the patterns and the rules as set by the conversational channel. And so as a solution provider, that makes our job a little easier, and it makes it certainly faster. So that's component number 1. But now here are the 2 sort of main pieces of what makes a conversational assistant. The actual natural language processing, natural language understanding, and what we call dialogue management. So I'm going to spend a bit of time going through both of these boxes in some detail. But the idea here is that the assistant doesn't just respond based on what it has talked to you, based on your words. It also has to get knowledge and data and insight from some other source. And one of the most important things that we see here is that there is a vast amount of investment being made by companies in building very, very solid backend systems. You can think of the SAPs of the world, the Oracles of the world, the CRMs of the world. There are all these backend systems that contain a ton of data, all the e-commerce systems that are out there. And so the idea behind the assistant is that you are abstracting out all the complexity of that system, and you are talking to your user in a very easy to understand human-like manner. And I just want to let that pause for a second, right? Think of either the corporate system or a non-corporate, even like Amazon.com. You go to Amazon and you are bombarded with information from all sides. Ads are playing. You have like God knows how many products, they're competing, there's rich text, there's images, it's just all coming at you. The idea behind the conversational assistant is a different flow which says, hey, look, I got all this information in the back end, but I am going to surface it to you in a very easy to consume, quick manner. And therein lies the trick, therein lies the skill in building a good conversational assistant. My sort of favorite example that I use when I'm talking to smart customers is, it's like my wife who goes shopping, who used to go shopping when she was in India. She would walk into a shoe store and the shoe shop guy was not going to say, hey, let me walk you through every lane that I have in my store so that you can pick one. No, he talks to her. What kind of a shoe are you looking for? He maybe asks one or two questions. And based on that, he doesn't go about and say, here are 100 shoes that you can choose from. No, he will bring her 3. And then she's going to say, wait a minute, I like this, but not that. And he's going to keep that in mind. Oh, she doesn't like this one. So then he's going to keep that to the side and get more based on what she likes. So it's an interaction, it's a discussion. And as part of this discussion, the assistant is learning about the customer. He's asking intelligent questions. And note that the assistant is not just some random guy off the street, but he's been owning and running that shoe shop for the last 20 years. So he knows something about shoes. And that essentially is what you want to replicate with all of these components of your conversational assistant. You want that understanding, you want the sort of polite interaction, and you want the knowledge that only years of experience can provide, all being distilled into a 2-sentence response back to the customer so that they get exactly what it is they're looking for. Okay, that being said, now let me get a little more technical and jump into the actual components. And I'm going to cover the natural language processing bit and the dialogue management piece. Conversational channels are fairly obvious. Backend systems are all custom based on the problem you're trying to solve. So we'll stick to these two for now. Natural language processing. So what Suva talked about was he went under the covers to see exactly how the algorithms work. What we will say is, we'll say, okay, we'll assume that these work, and we will use these models to actually solve the problem we have, which is of understanding what the input text is saying. So usually there are 3 or 4 steps in this process. It starts with the raw utterance from our human. And the first thing you do is you take it through something called a tokenizer. Most of these words are very fancy, but if you think about it logically, all that it is you're pre-parsing the data and you're breaking it out into chunks. You have a full sentence. Well, you can't deal with the full sentence, you're going to chop it out by words. And so how do you know what's a word? Well, you look at a space. And there are different ways of creating tokens. But essentially, you can think of it as splitting the raw text into pieces that we want to use. Here is where the next step, the featureizer, is where the actual machine learning magic comes into play. Where, as you remember from Suva's conversation, most of these models are nothing more than converting these words into numbers, running some highly specific algorithms on these numbers, generating the output of these algorithms, and translating it back into words. And so the featureizer is one very important part of it, where it generates these feature vectors from the raw text that has been provided. And these could be sparse or dense, as the case may be. Either it is very sparse in that it only has a few data points, rest are null, or a dense vector. And the important point I wanted to make here is that many of these are already done. There is BERT, and there is Glove, and there is Convert, and there is Spacey, and there's all kinds of things out there. From our standpoint, the challenge is, hey, for the problem we are trying to solve, which of these big guys' solutions is going to give me the best performance? So our problem is not that I'm going to go and tweak and make Spacey better than what it is. Sure, you can do that, but that's a very difficult problem to solve. An easier problem to solve is, hey, if I'm trying to do, say, if my customer is an organic products shop and I want to build a conversational assistant for them, how can I best extract feature vectors out of words that are in the space of organic products? So it becomes a choose the right tool rather than build the tool itself, which, by the way, in and of itself is a pretty sophisticated problem to solve. So technically plenty difficult in and of itself. Once you got that, then of course the key thing in the NLU stage, the NLP stage, is you break it down to try to understand the intent. What is it that the user is wanting to achieve? And then you try to extract, hey, is the user providing any information to me that I can make sense of? Are there people names or places or dates and times, currencies, things like that? So one example of an input text would be something like you say, I'd like to make an appointment for 2 o'clock tomorrow. So that's the input that the user has uttered. Well, you can break it out into pieces. You can do this featureizing. But the most interesting part after all this under the scenes, behind the scenes calculation is, did you get the intent right? And the intent here is, I'd like to make an appointment. And then, did you get the entities right? Which is, hey, he's saying 2 o'clock tomorrow. Chances are it's not 2 a.m. Chances are it's 2 p.m. What does tomorrow mean? Which time zone are you in? And accurately figuring out that, hey, you are Pacific time zone, you wanted to make an appointment for 2 p.m. Pacific on whatever, August 26th. So the goal of this particular piece is to start from that statement and finally give you these intents and entities for the assistant to then process. Okay, so I want to do a bit of detail about this. Let me now move forward to the dialogue management section. So now if I go back again for a second to the flow, remember this, we've got the channel, the person made a statement, and now we are saying, and now we have interpreted it, and now we're going to do something about it. And so dialogue management, again, you've got the entity, you've got the intent, and you need to decide how you're going to respond. Once again, you can be rule-based here. So you could say, I'm going to be machine learning based for the NLU portion, but I still want to take rule-based responses. Sure, you can do that, but same challenges as before. They are deterministic, but they're not scalable. Or again, you can do some machine learning based answers, which are extremely scalable, but they are probabilistic in nature, meaning that the assistant may not make the same decision for the same input each time. And what I found in practice is that a combination works best, especially given you will see some of the scenarios that will get very complex very fast. So this slide actually might have been better even a couple of slides before. I just wanted to show you how context is important. And this is an old slide from Google. But here's a sentence. The animal didn't cross the street because it was too tired. Well, you and me, humans, know that the word it here refers to the animal. The second sentence, almost exactly the same. The animal didn't cross the street because it was too wide. Well, now the it refers to the street and not the animal. And these are things we are taught in English Grammar 101, but it is surprising how phenomenally difficult it is to get that absolutely correct in every case for a chatbot or a contextual assistant. But this is exactly the kind of problem that you need to solve. Otherwise, your users are going to find it to be a not so interesting of of a chatbot. And so how do you solve this? One of the techniques, and Suva briefly touched on it, is RNNs, recurrent neural networks. They are very common modeling techniques. But I'd like you to see this one sort of example here. Take a moment to read it. That a real world conversation typically takes multiple turns. As a human, you are adept enough to know and hold that previous thing in your head. The thing with the RNN is that because of the importance that the RNN gives to the most recent utterance, it can completely change the dialogue flow itself. So we have a slide enhancement on top of RNN, which is this transformer embedding dialogue policies. Again, the details of these are available online for whoever wants to get into the details of the math. But the idea here is that this particular algorithm evaluates the different parts of the conversational history dynamically. So in this case, the assistant is saying, your total is this much, shall I charge the card you used the last time? And the human is saying, oh, do I still have credit on my account from that refund that I got? So sure, it needs to answer that question, but it needs to remember the fact that, hey, I am still at that probably checkout stage where I need to charge the card. You answered that. Now the human completely takes a different turn and says, hey, are you a bot? So detect the fact that, hey, this particular thing is merely chit chat, general question, give a general answer, but bring the user back to what was the important point. You want to collect their money. And then, of course, this example gets even more complicated. Oh, yeah, sure, but take the last thing I added out of the order. They've not said what that last thing was. And the assistant is smart enough to say, hey, I'm removing this reusable water bottle. And now, in fact, now what I should have done here in this example is say that your new total is 1225. Shall I charge the card you used the last time? And so that's when the user says, go place the order. So what I wanted to point out was the fact that the flows are complex. There's a lot happening behind the scenes, but you have a decent enough toolkit out there now that can sort of help build a bot that can solve these problems. Okay. So now again, I wanted to, so now that we've looked at a little bit of the architecture here, looked at the components, looked at what the ecosystem looks like, I wanted to sort of give my highly opinionated list of the things that are important in 2020 when you are out to build a conversational assistant. Now, in my mind, these problems have still not been solved. There is still plenty of scope for getting some of these right. In my mind also, I have not seen any single person who's the expert at everything. Maybe Google is, but I don't know anybody else. So therefore, there's a lot of room for highly targeted, highly industry specific, highly focused conversational assistants that solve a particular problem, but solve it really, really well. So here are some of the things that I would like to see happening in 2020 as this field matures. An industry-specific language. I think this is absolutely key. If you look at the advances that have been made in the field of machine learning, you'll find all these, Glove and BERT and all these are excellent corpuses of words. But the moment you get into industry-specific, those break down. So no matter what your industry is, right? I mean, it's I don't know, medicine, or it's industrial spare parts, or it is the world of art. I mean, every industry, every field has its own language. The conversational assistant should be able to kind of go and deal with it. Contextual understanding is key. People are making a lot of strides in this field so far already, but still not there yet. Just especially given how well humans can keep things in their heads, assistants are not there yet. Now, which brings me to this next point, right? A very fluid, very human-like experience. What gets tricky is the responses back are also very stilted. This is where you will start to get into things like a tone and empathy and understanding and things like that. You don't want to make the person feel like they're talking to an inanimate object, but rather something that understands and uses the right words in the right context is something that's very key. Tapping into existing corporate systems, we briefly talked about this. There's a lot of sort of structured data out there, a lot of systems. And so, for example, if you're talking about customer service, say, you should get the same response no matter if you're talking to the chatbot or if you're going on the website and looking at it yourself. It should come from the same system, same data, same experience, should not be anything different. Personalization, going to be an absolute key. I think, and in fact, this I think is one of the big selling points, one of the big plus points is that there is capacity for infinite personalization, especially if you're coming from a platform like Facebook Messenger. Depending on what information you choose to share, the assistant can already know a lot about you. And so don't ask the same question, don't ask what you've asked before, remember what I said with my likes and dislikes before, things like that. And that ties into self-learning in that got to get better over time, got to get more cases, more data, more knowledge, and be able to leverage that in a way that's pinpointed for the user. So I go to a product on Amazon and that has 800 reviews. How many of us are going to read 800 reviews? We're going to read 3 reviews. But what if the assistant, having read all the 800 reviews, knows a little bit about me and says, hey, for you, I think these 3 things are going to matter for you. And so you might want to check out these reviews. Or for example, oh, here are 3 products that you're considering. I think other people like you have bought this one more than these 2. So these are all kinds of insights. And these insights, they are very simple to provide, seemingly trivial, but the back-end complexity that is required to generate these insights is phenomenally difficult. But tapping into all of these systems, generating that personalization and learning from it would be key. Analytics, one of my favorites. I mean, I've been investing in this space for whatever, 20 years now. They offer a wonderful potential for knowing exactly what happened. Imagine that you're in a call center and every conversation is instantly annotated and available as to what was done, what was good, what was not good. It can be a very, very powerful experience. And then the other thing is, of course, that one cannot be all things to all people. I mean, that kind of applies to that. Maybe that statement doesn't apply to Google, Facebook, Amazon, and Apple and all that, because they are all in the business of being all things to all people. But then they are fighting amongst each other. We here are sitting and solving a very specific problem, leveraging their technologies. So I think that investing in either a particular business process or a particular vertical that really gives a phenomenal customer service experience is a very valuable thing even in 2020. I'm sure there are a lot more items that you can add to it and people have their opinions as well, but just from what I have seen in the market, these are some things that will hold a lot of weight going forward. So I wanted to pretty much wrap my talk today with just a little glimpse of what are some of the use cases that one can solve with this. These are just about the tip of the iceberg. There is so much in each of these that it's very difficult to even cover them as opposed to going into a broad solution. There are use cases in terms of PPC, online marketing. Customer service is a huge, huge thing. Simply knowing who the customer is and what their problem is and giving them a fast answer before they can even go talk to a human, it would be fantastic. E-commerce, Big deal. I mean, Amazon stock has gone from where to where only in the last 4 months. So this is, of course, the big daddy in terms of where all the spend is. Things like inside sales, appointment booking. You can imagine somebody is trying to make a phone call and you don't have the people that are there to answer the phones. And so a virtual assistant can answer the phone and go ahead and do at least the initial analysis and booking of the appointment. Healthcare is a fantastic example of where personalization comes into play. Every problem is unique. And so you need to be able to know the history, know the sort of unique circumstances, and then and only then be able to answer. Help desk, this is like a 101 use case, especially in cases like IT help desk, the same problem occurs so many times. And so if the assistant can reply, nothing like it. You save the tech from having to reply and having to answer. So point being that literally every sort of field of activity that we see out there is ripe for a conversational assistant type solution. They all sort of fall into a very similar sort of flow in terms of, yeah, there's some problem that you want to solve. There's some language that's associated with the problem. You need to understand the language. You need to make sense of it. And you need to construct a solution that gives the user the most effective answer back. So the tech stack is there. Quite a bit of it is being built out there right now. But the field is very ripe in terms of building real world value added solutions on top of what we've got. So I think that was pretty much what I had in terms of prepared material. I would love to take questions, comments, any feedback that anyone might have on this, or maybe even the previous topic that Suva talked about.
First of all, Rishi, on behalf of all of us, thank you. This was absolutely phenomenally, informational session. I do have a bunch of questions, but we have folks on the bridge, so please ask your questions over to Rishi. So while we wait, Rishi, there are a couple of questions on the chat. So let me ask you first. Sujata is asking if you could provide some material to learn more about natural language understanding and natural language processing, NLU, NLP, either courses or website links that provide information on these things and potential technical projects if people want to learn.
Oh yeah, absolutely. So some of the things that I have found very interesting about natural language processing. So actually, let me just step back for a minute. There are two sort of perspectives on that question. One perspective might be to understand the core of how those algorithms work, what makes them tick. So for example, how do they do word to vec, for example, or how is glove created, the actual math behind it. So there are courses on both Coursera and Udemy that talk about this, that are pretty detailed and pretty good. Lot of material on Stanford's glove webpage. Google has got BERT that talks about it. Facebook has got Fast Text that actually talks about some of these things as well. So there's just a wide variety of information on the guts of what the algorithms are. Then there is the field of what I would call applied NLP, which is to use the existing algorithms to solve the problems that you might have. And for these, you can look at some of these software as a service providers. So Amazon Lex has some very good information. Microsoft Lewis has some very good information. Google Dialogflow has a bunch of good information on how it uses some of this natural language processing. And finally, you can put together some of your own things by simply downloading some of the most common libraries like Spacy. So you can download Spacy, you can download Fast Text, and you can actually just write a very simple Python program, download it, pass it a word or pass it a fragment, and you can see it apply it to your use case. So depending on what level you want to go into, there are sources for getting into it. Hopefully that answered that question.
Absolutely, Rishi. Thank you. Thank you. And Sujata says thank you as well. Thank you, Sujata. Yes. So a lot of folks have asked if we can share the recording with them. So yes, we are recording the session and we will be sharing it with you as well. Folks, please ask more questions. I have many questions, so I want to go last. Okay, then, while we wait, a couple of things. I know you mentioned about the Turing test, Rishi, so just for the benefit of everyone, right? So folks, a Turing test is nothing but a way to determine, like it's a blind test to see if a third-party observer can differentiate between a machine and a human. And if they cannot, right? If they cannot distinguish, okay, the output is coming from a machine or a human, it means that the machine or the software has passed the Turing test, okay? So, and essentially that is what Rishi was trying to say here, whether or not with some of the recent, advances in chatbot technology, whether or not we have reached a point. You've seen the example that I shared regarding Google. If the person taking the order in the restaurant was not able to figure out that it was actually a bot that was calling the person, then of course that means it has passed the Turing test, right? So, any other examples, Rishi, that you can think of?
No, but that point itself, right, is a very, very important point. Is that the ability to impersonate a human, especially when it comes to all the various turns and the jumps that the human mind can take. We are no doubt making very, very rapid strides in this, but as a generic solution, there still remains a very ripe market to exploit. And to me, that's a good thing that these guys have built all these fundamental techs that we can build on top of to solve the specific problems that are in our industry. So from my standpoint, it's a good thing where we are. It's not like it was a few years ago that there was nothing in place, and neither are we at a point where all the problems have been solved. So it's a good point to be in.
Yeah, absolutely. Any questions? I think Prasad, you had a question.
Yes, I have a question. Thanks for the wonderful session, Rishi. I was curious, I'm new to the data engineering world. So I was just curious about how the data models being tested. Like initially you mentioned about some point like the testing the data models, some data models may not be accurate and there is so much of work going on. So can you please highlight a little bit on that?
Yeah, absolutely. So from a sort of conversational AI perspective, right? All of that kind of work gets done here. So it is this featureizer that says, I have this sentence and I am going to build a vector representation of this sentence. So that is extremely dependent on the context. So that work to take the entire corpus of the English language and some other languages as well, these big guys have done a lot of work around analyzing it and building their own sort of models. And essentially the model is nothing more than creating a mathematical function of out of all of those words. And typically to do that, they use some of these very large corpora that you have out there, like the entire Wikipedia data set, for example, right? And then each of the models gives you different performance, depending on what your industry is. So if you are, like I said, right, if you are dealing with, say, industrial spare parts, then words like bracket and engine and all of these might mean something different than what they mean in ordinary speech. And so if you are using a model, Word2Vec or Glove or any of these that has been trained on ordinary speech, it might not work for the industry that you're talking about. And that is where you need to do a little bit more sort of extra work to take your own corpus, your own data set, get it converted into vectors and use that as a part of this featureizer set so that you can understand. So that is sort of modeling as it refers specifically to my sort of chatbot space. In general, though, the question you ask may also be about building machine learning models in general. And that is also an art form now, where you have a particular problem that you're trying to solve. And the question in front of you is, which model should you use? There are all of these things, right? I mean, random forest and this and RNN and CNN and all these things. Which one should you use? Because each has its own quirks and each has its own sort of knobs and dials. That, unfortunately or fortunately, you have to get a slightly better understanding of your problem statement. And then there are certain algorithms. I think Suva had one slide that kind of talked about how the various models are broken out, depending on the kind of problem that you're trying to solve. And so what you typically do is that you typically take one, start, look at the error rate, and then either fine tune the model or you take one more model and try to work on that. So you try a couple of different models and you work there. One last point I'll make on that, just to kind of illustrate where the field is going, is that Microsoft, for example, now, the Azure Machine Learning Studio, it says, hey, you don't even need to select the model. You simply give me your data set prepared in the right way, and I will automatically throw every model at it and show you what the output looks like with the error rates, and you can decide whichever is the best and you can pick it. So you can see there is so much automation happening in this field. Who knows what will happen 2, 3, 5 years from now. But that's kind of where we are at the moment. Does that answer your question?
Yeah, it answered my question. Yeah, thank you for clarifying it. And one more follow-up questions. These the models are generic, or these are specific to some data set or to the domain, or say for example Amazon. Amazon sells different products, but if you take like Kohl's or Macy's, they sell products specific to clothing. So my question was is these models generic or industry specific or like customizable?
Yeah, so, and this is kind of going a little bit into some of the work that we are doing at Talking Mart. Exactly, that's the problem, that most of these models are very generic and they do not perform so well when it comes to your specific industry. So you need to tweak it a little bit. You need to customize it. You need to give it that little bit of correct training data to make it work for your space. So clothing, for example, right? Clothing is such a subjective field. In fact, that's a great example. If you look at clothing versus, say, the industrial spare parts that I talked about, industrial spare parts, things are fixed. If there is a particular part that is needed to fix a particular machine, then it is only that part, and it can only be described in a particular set of words, particular language. In the case of clothing, things are very fluid. And that a lot of it is often open to interpretation. So what I would do in terms of clothing, for example, is I would definitely go for an industry-specific data set. I mean, start with the base model. And I would definitely go for an industry-specific data set. I use it to fine-tune that model in such a way that I give heavier weights to industry-specific terms. And you will see that being reflected as the chatbot responds. You will see it automatically giving weight to words that are more important for your industry than not. And that's where that's the bit that's a little bit of an art, and that's what makes the field still so interesting. It's not all solved by Amazon and Google. There's still a lot of room for us to go and build some new things out of it.
Yeah, got it. Thank you so much for clarifying.
Anything else?
Come on, guys, questions? Okay, while we wait, Rishi, let me ask a quick question from my end. So we have, a few folks who are part of our data science cohort. So we did talk about the RNN model with them in detail, last year. So they understand the challenges of the short-term memory, and that some workarounds involve a couple of solutions. There's one LSTM called long short-term memory using gates, right, which sort of amplifies some of the older signals, if you will, so that the older memory, at least the slightly older short-term memory, is not lost. There is, I believe, also a gated GRU kind of a solution, which are all derivatives of RNN. And I think in your particular case, you had called out a specific alternative to RNN. Without going too much into the details of the mathematical model around it, the transformer embedding dialogue policy you had mentioned, at a conceptual level, how is it different from RNN? I'm just curious from a mathematical perspective.
So essentially, what it does, right, is that the TED policy, the transformer embedding dialogue policy, what it does, its focus is really on these nonlinear conversation. So what it does effectively is that in the case of an RNN, it commits every user input to memory. The TED actually looks to forgetting a piece of it. It just says that some things are not so important, so I'm not going to give it a higher level weightage, and I'm just going to take something else, and that makes it much better. So it looks at the input, the previous system action that was predicted just before, and then any values that are saved in the memory as slots. What it does is that it recalculates this every time, every step of the process, and every time that if the utterance that you make is completely different now than what it had before, it's not a problem. It just uses that. In terms of the sort of technical detail, it applies a dense layer to get the embedding. So I mean, that part is very similar, right? You're looking at some word embeddings to convert that into vector. But it essentially gets the embeddings for the new one. It calculates the difference between this and the previous one. And then it tries to essentially find the one that is closest to the target that you want. There's a particular algorithm that it uses called the star space algorithm. But at a very high level, that's kind of how it works.
So that's fantastic. So essentially what you're saying is I don't need to know or remember everything about the history as long as I have important contextual information that is worth remembering, right? And you make that determination. What is worth forgetting versus what is worth remembering.
Exactly.
Okay, got it. Any questions from the audience? We will wind up in just a couple of minutes. Thank you for your patience, folks. Okay, so let me ask the question in a couple of different ways, Rishi. The folks on the call today are either enthusiasts, who want to learn more about AI and machine learning, and chatbot is definitely a happening thing, right? So actually I have 2-3 questions maybe in this area. One is IVR, right? The interactive voice response that is employed by, many companies these days when you call them over the phone. They do recognize your voice, they do recognize what you're asking, but then from a model perspective, it seems fairly deterministic, that as in on the back end, they have a set number of menu items and they're essentially interpreting what you're asking for and choosing from one of several menu options, and that's about it, right? So there is no fuzziness to it. That's on the one hand, right? And then you have these chat bots, which are conversational bots, wherein you actually type in the content. And then of course you have these voice-driven assistants like the Alexas, the Cortanas, the Siris out there. Now, are you seeing some kind of a convergence among all these 3 different interfaces into a singular engine?
So that's a very interesting point. I mean, I am utterly convinced that these guys, the big guys, your Alexas of the world, they are the kind of data that they have, I mean, nobody else has. So I'll break your question up into two parts. First, the voice portion of it. Voice is here to stay. Voice is not going to go. But the capability on voice to text is very sophisticated now. So almost in real time, you can take that voice, you can convert it to text, and then after that, it becomes nothing more than a text analysis, and you can do the same kinds of algorithms as before. So voice is definitely a channel, and but as far as interpreting the voice itself, not much. Convert it to text and do what you want to do with it. As far as these guys go, the big guys, just given the vast amount of data that they have, the quality of their algorithms are definitely better than anything else anybody else can come up with. So tomorrow, if they want to get into a particular space, they very much can. But so far, they've kind of stayed on the generic side of the house. And in many ways, right, solving a generic problem becomes very tricky as opposed to a very specific problem. Hey, I want to have a help desk solution that is going to answer the most common questions that my users ask me. Fantastic. You can do that with anything you want. It's your data, your sort of corpus, your lingo, your solution, and it solves your problem. I think that's a lot better for people like us than thinking that broad in terms of solving a Hey Google or a Alexa level problem. That being said, though, these are good channels. So Alexa, you can build skills on Alexa with whatever you have to offer as well. Or ordering a product on Amazon through Alexa is a thing that they've been working on as well, quite a bit of. So you could definitely do something specific on these big players as well.
So one last question from my end, Rishi, this is very helpful. Is now, what if we have some, entrepreneurial aspirations, and we like working with NLP, and we are exploring this. Now, most of the systems seem to be closed, right? So if I were to build some kind of an assistant that would sit on top of, say, Amazon, how easy is it to go about that? Or do I have to be part of Amazon to be able to do it, right? Because right now, for example, as a user, all of us are overwhelmed. There are like what, even on a single page, 100 recommendations sliced in different dimensions, right? It is very overwhelming. So what is Amazon trying to say? Is it asking me to buy A or B or C? Every page has, scores, if not 100 recommendations. So it would be interesting to have a layer that I could potentially customize. Just your thoughts. Does Amazon itself have to come up with a solution, or are there? Just wanted to pick your brains from an entrepreneur.
So that's an amazing point. So I mean, that's a topic in and of itself. A friend of mine, for example, he hates the recommendations Amazon makes because Amazon only makes the recommendations to maximize their sales. Obviously, right? If I am them, that's what I would do. So the idea is to, even these recommendations, what is the logic behind it? Who is benefiting from that recommendation is a pretty big field out there. So as far as the entrepreneurial aspect of it goes, from our Talking Mart perspective, that's one of the things that we focused on, which is, hey, Amazon will give me 100 recommendations, but our play is that, hey, you give three that are easy to consume, three that are very relevant, and three that help the user. So the user only has to pick one out of the three. Much easier decision than picking one out of 50. So from that standpoint, I think there are plenty of opportunities in terms of recommendations and how to drive those. As far as the model itself goes, you can build it a lot on personalization. What does the user want? Most importantly, what do they not want? And you have a relationship with them. They've bought from you before. They've chatted with you before. Based on that, you can make it very, very personal.
Got it. So there are 3 questions on the chat window. In fact, you might be able to see it too once you start.
Yeah.
So we'll go with Deepa first. She has asked, to get into this chatbot NLP space, what kind of skills are needed? Python, SQL,
Yeah, so that's kind of an interesting question, Deepa. Depends on what you want to do. So for sure, anything to do with machine learning, Python is always a good skill to have. And I would probably add another good skill is Python specifically on Linux, because that is like the easiest. There are lots of packages out there for it. You can create virtual environments very fast. I mean, Windows is not bad either. Mac is not bad either, but Linux by far is the easiest in terms of this. So Python is always good to know. Specifically when it comes to chatbots and virtual assistants, I am finding that it is more than just the nitty-gritties of Python, because that problem is not that you can even have a developer that does some amount of fixed Python coding and that's it, you're done. The hard part in this is to actually design that conversation. So if you look at the conversation that I have on my screen, that is a phenomenally complex conversation. How to understand the language processing, how to understand the dialogue policies, how to get all this data back. Yes, your account has $10 in credit. To interpret the fact that my account means the user ID, who you're talking to. These kinds of sort of architectural, conversational skills are almost more important than pure Python. But Python is of course a nice 101 thing. As far as SQL comes, there are many flavors of SQL out there. If you are specifically referring to Microsoft SQL Server, that entire ecosystem has got a phenomenal set of tools out there as well. So Microsoft is making a big push on SQL, all of Python, machine learning, all of that is there. So point being that no matter where you come from, you probably have a good sort of solution that you can, a good set of tools that you can leverage to go and get into this space. Hopefully that answers your question.
Yeah, thank you, Rishi. Deepa, if you have a follow-up question, please feel free to type in or ask. Anand has a question. How do we train the bots themselves?
Yeah. So that's a very good question. I left that part out of my presentation today. But effectively what you're doing is, the simplest way is to think of it like any other machine learning problem, where you give it training data, you fit a model, and you look at the error. So in this case, what you do is before you give it, so you have to give the training data in somewhat of a structured format. You basically build the conversation. So you have some sample conversations that you build. You feed those into your models. And by models, I mean here. So you feed some of those sample conversations here. You say that, and you manually label, oh, I want an appointment for 2 p.m. Want an appointment, that's an intent. 2 p.m., that's a time. So you give it some training data. You don't have to give it a lot, some reasonable amount of training data, and then you start to run these models. Under the covers, the models are the very same machine learning models that Suva talked about, but they are now used specifically in the case of the chatbot, and then that's how the model trains. Ultimately, the best way to then train it is to have real-world data from real-world people, and use that to constantly make the model better. And the specific act of training the model itself is, you would run something, depending on which bot platform you're using, you would basically execute a command either through a UI or a command line, and that would essentially take the latest training data and recalculate and rebuild the model.
Excellent, Rishi, thank you so much. And yes, at the end of the day, it is a model, right? So you would treat it the same way as you would do any regular AI or machine learning model.
Absolutely.
Yeah. And of course, by the very nature of it, it would fall under the quote unquote supervised learning model, because you are
very much so.
Yeah.
Very much so.
So Sunil Tripathi has a question in terms of the learning curve for all of this, and I know it's a very open-ended, broad question, but he's asking, what's the typical learning curve for those interested in learning AI and machine learning?
So the way I would typically answer that is I would ask what your objective is out of this. And so there can be a couple of different objectives, right? One objective could be to simply be um, a machine learning programmer who knows all the tools that are out there. While if you want to be that, then yeah, you got to go look at all the models and you have to see what the model parameters are and when to use which model. So you are sort of a model selector. But like Suva, you had a slide where the actual machine learning portion of it was like 5%. 95% of it is a lot of the ancillary information. Deepa mentioned the point about SQL, right? A lot of data munging is very critical in this. So getting the data, preparing it, munging it, cleaning it. So there's a whole set around the data side of it. Tuning to actually use the output, eliminating things like AI bias, that in and of itself is a field. Very important in terms of making sense of the output of the model. And so that requires pretty deep domain knowledge and understanding what it is that you're trying to do out there. So depending on what your objective is, there are different sort of paths that you can follow. The most typical question that I get asked about is how do I become an AI machine learning developer? And then for that, you have your courses that you take. There are plenty good ones out there that you can take that will get you started. One last point, if you say that you want to get into the math behind it, then that's a master's or a PhD level course. That's a different story altogether. But most people don't kind of go to that level of detail.
Yeah, absolutely. Absolutely. Thank you, Rishi. And folks, feel free to ask further questions via email. I will be sharing, for those of you who need it, I'll be sharing the recording link as well as the slides for my presentation, as well as the presentation from Rishi. Any final questions before we wind up today? All right. Rishi, I know this was a little bit of a stretch. We are almost at the 2-hour mark, and I know you have a very busy schedule and you're working on a cool product. Good luck with your product. And we really thoroughly enjoyed the conversation today. On behalf of BayOne and all of us on the bridge today, thank you very much. I hope to see and hear from you again. Thank you.
Thank you so very much. Glad to be here.